students, I am Ekta. Children, factorize the number 240. 24 into 10, 8 into 30, 12 into 20, 15 into 16. Which answer is correct, children? Yes, all the answers are correct. How? Split each of the factors into the product of prime numbers. 24 into 10 is equal to 2 into 2 into 2 into 3 into 2 into 5. 8 into 30 is equal to 2 into 2 into 2 into 2 into 3 into 5. 12 into 20 is equal to 2 into 2 into 3 into 2 into 2 into 5. 15 into 16 is equal to 3 into 5 into 2 into 2 into 2 into 2. Now count the number of 2's, 3's and 5's. Finally, we got 4 2's, 1 3 and 1 5 from all factors. All the factors got 4 2's, 1 3 and 1 5. This is very surprising to you, is not it? Yes, it should be. Once any number is factorized up to a product of prime numbers, everyone should get the same collection of prime numbers. This concept leads us to the following important theorem. After the completion of this lesson, you will be able to know learning outcomes. To study the concept of the Fundamental Theorem of Arithmetic. To understand the Fundamental Theorem of Arithmetic. Keywords from this lesson: numbers, natural numbers, factors, prime numbers, arithmetic, composite number. Theorem, Fundamental Theorem of Arithmetic without proof. Every natural number except 1 can be factorized as a product of primes, and this factorization is unique except for the order in which the prime factors are written. The fundamental theorem asserts that every composite number can be decomposed as a product of prime numbers and that the decomposition is unique, in the sense that there is one and only way to express the decomposition as the product of primes. In general, we conclude that given a composite number n, we decompose it uniquely in the form n is equal to p1 power q1 into p2 power q2 into p3 power q3 into so on into pn power qn, where p1, p2, p3, so on, pn are primes and q1, q2, q3, so on, qn are natural. First, we try to factorize n into its factor. If all the factors are themselves primes, then we can stop. Otherwise, we try to further split the factors which are not prime. Continue the process till we get only prime numbers. Illustration. For example, if we try to factorize 32,760, we get 32,760 is equal to 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13 is equal to 2 power 3 into 3 power 2 into 5 power 1 into 7 power 1 into 13 power 1. Thus, In whatever way we try to factorize 32,760, we should finally get 3 2s, 2 3s, 1 5, 1 7 and 1 13. The fact that every composite number can be written uniquely as the product of the power of primes is called the fundamental theorem of arithmetic. Significance of the fundamental theorem of arithmetic. The fundamental theorem about natural numbers except one, which we have stated above, has several applications both in mathematics and in other fields. The theorem is vastly important in mathematics since it highlights the fact that prime numbers are the building blocks for all positive integers. Thus, prime numbers can be compared to atoms making up a molecule. If a prime number p divides AB, then either p divides A or p divides B. That is, p divides at least one of them. If a composite number of n divides AB, then n neither divides A nor B. For example, 6 divide 4 into 3, but 6 neither divide 4 nor 3. Example: in the given factor tree, find the numbers m and n. Solution: value of the first box from bottom is equal to 5 into 2 is equal to 10. Value of n is equal to 5 into 10 is equal to 50. Value of the second box from bottom is equal to 3 into 50 is equal to 150. Value of m is equal to 2 into 150 is equal to 300. Thus, the required numbers are m is equal to 300, n is equal to 50. Example: can the number 6 power n being a natural number, end with the digit 5? Give a reason for your answer. Solution: since 6 power n is equal to 2 into 3 whole power n is equal to 2 power n into 3 power n. 2 is a factor of 6 power n. So, 6 power n is always even. But any number whose last digit is 5 is always odd. Hence, 6 power n cannot end with the digit 5. Example: is 7 into 5 into 3 into 2 plus 3 a composite number? Justify your answer. Solution: yes. The given number is a composite number because 7 into 5 into 3 into 2 plus 3 is equal to 3 into 7 into 5 into 2 plus 1 is equal to 3 into 71. Since the given number can be factorized in terms of 2 primes. It is a composite number. Example, a and b are two positive integers such that a power b into b power a is equal to 800. Find a and b. Solution. The number 800 can be factorized as 800 is equal to 2 into 2 into 2 into 2 into 2 into 5 into 5 is equal to 2 power 5 into 5 power 2. Hence, by comparing a power b into b power a is equal to 2 power 5 into 5 power 2. This implies that a is equal to 2 and b is equal to 5, or a is equal to 5 and b is equal to 2. Example, find the remainder when 70,004 and 778 are divided by 7. Solution. Since 70,000 is divisible by 7, 70,000 is equal to 0 mod 7. 70,000 plus 4 is equal to 0 plus 4 mod 7. $70,004 is equal to 4 mod 7. Therefore, the remainder when 70,004 is divided by 7 is 4. Since 777 is divisible by 7, 777 is equal to 0 mod 7. 777 plus 1 is equal to 0 plus 1 mod 7. 778 is equal to 1 mod 7. Therefore, the remainder when 778 is divided by 7 is 1. Example, determine the value of d such that 15 is equal to 3 mod d. Solution, 15 is equal to 3 mod d means 15 minus 3 is equal to kd for some integer k. 12 is equal to kd. Gives d divides 12. The divisor of 12 are 1, 2, 3, 4, 6, 12. But d should be larger than 3 and so the possible values for d are 4, 6, 12. Example, find the least positive value of x such that 67 plus x is equal to 1 mod 4. Solution, 67 plus x is equal to 1 mod 4. 67 plus x minus 1 is equal to 4n for some integer n. 66 plus x is equal to 4n. 66 plus x is a multiple of 4. Therefore, the least positive value of x must be 2. Since 68 is the nearest multiple of 4 more than 66. Example, find the least positive value of x such that 98 is equal to x plus 4 mod 5. Solution, 98 minus x plus 4 is equal to 5n for some integer n. 94 minus x is equal to 5n. 94 minus x is a multiple of 5. Therefore, the least positive value of x must be 4. Since 94 minus 4 is equal to 90 is the nearest multiple of 5 less than 94. Points to remember. Fundamental Theorem of Arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique except for the order in which the prime factors occur. A composite number n, we decompose it uniquely in the form n is equal to p1 power q1 into p2 power q2 into p3 power q3 into so on into pn power qn, where p1, p2, p3 and so on, pn are primes and q1, q2, q3 and so on, qn are natural. Thanks for watching. Like, share and subscribe.